Alright, we're going to be first looking at the theorem of properties of limits, and we will not be proving any of these theorems here. We're just going to be stating them and then looking at some examples. So the theorem reads, let b and c be real numbers and n a positive integer, and let f and g be functions that each have a limit as x approaches c. So in this first property here, it's called the scalar multiple. We have the limit as x approaches c of b times f of x is equal to b times the limit of f of x as x approaches c. So as you can see here, we can take this b, this coefficient, and just bring it outside of the limit. Our next one we're going to look at is the sum or difference. If we have the limit of two functions, whether they're added or taking their difference, as x approaches c, this is equal to the limit of f of x as x approaches c plus or minus the limit of g of x as x approaches c. Let's take a look at some examples. So we have the limit, and this is our function here, as x approaches 2, and I'm claiming that it's equal to 7. Now in the sum or difference property, we can take these and consider these, this x squared, this 2x, and this minus 1 here as three separate functions, and we can actually split these up. However, later on this will not be necessary, but we're looking mostly at the properties of limits here and what we can do with these functions as we take the limit of them. So I've broken this up into three separate pieces. We have the limit of x squared as x approaches 2, the limit of 2 of x as x approaches 2, minus the limit of a constant as x approaches 2. And we do the direct substitution. We plug 2 directly into the function. We get 2 squared plus, and we have the 2 here. Now remember, this was the scalar multiple where we can take this number here, this coefficient of x, and bring it outside of the function. And we do the direct substitution, plugging 2 directly in for x, as you can see here. And we have 2 times 2 minus, and the limit of a constant is just the constant. And so we do the arithmetic, and our limit is equal to 7. Now I'd like to take a look at the graph. Okay, so here's a graph of our function, which is x squared plus 2x minus 1, and we were approaching 2. So we're going to locate 2 on the x-axis. Let's go directly up, and then we'll go across, and as you can see here, this is supposed to be 7 on the y-axis. So the way we look at these limits, remember, that we're coming in from the right-hand side and we're coming in from the left-hand side. So if we picked a point on the left-hand side of 2, something close, and we go up, straight up, right, find the point on the graph that's associated with that x value on the x-axis, and as we ride the graph going upwards, as our x value is approaching 2, as you can see here, the y coordinate is getting closer and closer to 7. And then we look at this from the right hand side coming in from the right. So I pick a point on the x-axis to the right of 2. I go straight up, locate the graph. Now as my x gets closer and closer to 2 coming in from the right, and I follow the graph down, my y value is getting closer and closer to 7. And we're looking at this here graphically, but we've actually done it analytically and showed that it is equal to 7.